Hey there, science fans. Today we're diving into the microscopic world of our bodies to uncover the drama of cancer. Picture this, trillions of cells working together, keeping you alive and kicking. These cells are the tiny building blocks of your tissues and organs. They grow, divide, and die off in a perfectly choreographed dance. But sometimes, a rogue cell breaks free from the rhythm. This happens when a cell's DNA, its instruction manual, gets damaged. These errors, called mutations, can occur due to various factors. Think of it like a typo in a recipe. It can change the outcome completely. These mutations can be triggered by things we encounter every day. Smoking, excessive sunbathing, or even just aging can damage our DNA. Some people inherit faulty genes, making them more susceptible to developing cancer. But remember, it's not a guaranteed outcome. Now, our bodies are pretty amazing machines, equipped with repair mechanisms to fix most of these DNA errors. But occasionally, a mutated cell slips through the cracks. This renegade cell starts multiplying uncontrollably, ignoring the rules and crowding out healthy cells. Congratulations, folks, that's the beginning of cancer. So, how do these cellular rebels manage to wreak havoc? They hijack specific genes that control cell growth and death. It's a full-blown mutiny within our own bodies. Let's meet the usual suspects, tumor suppressor genes. Imagine these genes as the brakes on a car. They keep cell growth in check and make sure damaged cells are sent to the scrapyard. But when these genes are mutated, the brakes fail and cells multiply out of control. It's like a car stuck in overdrive. Oncogenes, these genes are like the gas pedal, encouraging cell growth and division. Mutations can jam the pedal to the metal, causing cells to proliferate at an alarming rate. It's like the car is stuck on a runaway train to Cancer Town. Apoptosis disruption. Every cell has a self-destruct button called apoptosis. It's a neat trick to eliminate damaged or unnecessary cells. But cancer cells can disable this button, becoming immortal and unstoppable. They're like zombies that refuse to die. These genetic changes transform a well-behaved cell into a dangerous outlaw, capable of invading nearby tissues and even spreading to distant parts of the body. That's when things get really serious. Luckily, our bodies aren't defenseless against these cellular outlaws. We have a crack team of bodyguards, the immune system. This complex network of cells and proteins constantly patrols our bodies, searching for anything suspicious. Think of our cells as carrying ID cards called MHC Class I molecules. These molecules display snippets of proteins made inside the cell. The immune system uses these ID cards to recognize friend from foe. Enter the T cells, the elite force of the immune system. These highly trained cells can identify and destroy cells displaying abnormal ID cards like those held by cancer cells or virus-infected cells. Talk about a cellular beatdown, but wait, there's more. Natural killer, NK cells, are like the immune system's secret agents. They can detect and eliminate cancerous or infected cells, even if they try to hide their ID cards. They're the ultimate assassins, taking out the trash. Section 4, a sneaky foe: cancer's tricks and disguises. Unfortunately, cancer cells are masters of disguise and deception. They're constantly evolving, trying to outsmart the immune system's defenses. It's a constant game of cat and mouse. Some cancer cells mutate to avoid detection, camouflaging themselves as harmless cells. Others release substances that suppress the immune response, effectively blinding the bodyguards. It's like throwing a smoke bomb and disappearing into thin air. Cancer cells can even evolve resistance to treatments, making them even tougher to eliminate. This constant adaptation makes cancer a formidable foe, requiring innovative approaches to stay one step ahead. Section 5. Fighting fire with fire, harnessing the immune system. Despite cancer's cunning tricks, scientists are developing groundbreaking therapies that harness the power of the immune system. It's like giving our bodyguards the tools they need to win the fight. One promising approach is engineered T-cell therapy. Imagine taking T-cells from a patient's blood and giving them a super upgrade in the lab. These genetically modified T-cells are trained to recognize and destroy specific cancer cells with laser-like precision. It's like creating a personalized army of cancer-killing machines. Another exciting avenue is cancer vaccines. These vaccines work by teaching the immune system to recognize and attack cancer cells. They're like wanted posters, alerting the bodyguards to the presence of these cellular criminals. The fight against cancer is a complex and ongoing challenge, But by understanding the intricate dance between cancer cells and the immune system, we can develop innovative therapies to outsmart this formidable foe. Stay curious, my friends, and keep exploring the wonders of science.